Now, good news for IIT and JEE aspirant. Those who are preparing for IIT JEE NEET and want to learn organic chemistry from me can join through YouTube by membership program. Just click on the join button and join our champion course. Now, hello to everyone. How are you? Today we will start isomerism. We will learn how to differentiate different type of isomerism, how to draw isomerism. So, our topic will be isomerism. So, let's start with isomerism. So, first of all, what is the meaning of word isomer? Word isomer means kya? What is the meaning of word isomer? Iso means same. Mer means unit. So, same unit is known as isomers. And the phenomena of isomer is known as isomerism. Similarly, what is the meaning of word dimer? Di means two, mer means unit. If we combine two units, if there is any process in which two units are combining, this means it is known as a dimer, or the process is known as dimerization. Similarly, what is the meaning of word polymer? Poly means many, mer means unit. Many unit is known as polymer. Got it? So, what is the definition of isomerism? The phenomena of isomers is known as isomerism. Write in your notes, the phenomena of isomers is known as isomerism. The phenomena of isomer is known as isomerism. Write all these terms: isomer, dimer, polymer. I will show you one image. Just watch that image and you will able to differentiate between isomer, dimer and polymer. Now, let us differentiate different type of isomerism. Basically, there are two type of isomerism. One, from this image we can easily visualize that first one is monomer, single unit, second is dimer, 2 units, and last one is polymer, many units. One is our structural isomer and second one is our stereoisomers. Now, what is the difference between structural isomer and stereoisomer? As the name suggests, structural isomer means there is a change in different structures. And what is the isomer? Isomer have same molecular formula. Same molecular formula but different structural formula is known as structural isomer. Isomer has same molecular formula but different structural formula. While in case of stereoisomerism, they have same IUPAC nomenclature. In case of isomerism, stereoisomerism, we can do what we are exactly doing. We can draw mirror image, we can interchange valencies, or we can rotate bonds. So, basically in stereoisomerism, we are not changing structures. In structural isomer, we are changing structure. This means structural isomer has different IUPAC name. If you change the structure, this means IUPAC name will be different. While in stereoisomerism, have same IUPAC name. We are not counting RS, EZ nomenclature in this. Same IUPAC name. Now, structural isomer is further classified into chain isomer, positional isomer, chain isomer, positional isomer, functional isomer, metamer, ring chain isomer, tautomers. They all are structural isomers. They are types of structural isomers: chain, positional, functional, metamer, ring chain, tautomer. So, first of all, write all these structural isomerism in your notes. While in case of stereoisomers, it is further classified into two categories. One is our conformational isomerism and another one is configuration isomerism. One is conformational, other is configuration. Now, what is the meaning of conformational? Further, conformal means isomer found by flipping or found by rotation across bond. It is further classified into two categories. One category is rotation across sigma bond. And it is also known as amine inversion. While in case of configuration, it is further classified into two categories. One is optical isomerism and configuration isomerism classified into two categories. One is optical isomerism and another one is geometrical isomerism. GI means geometrical isomerism. So let's start with chain isomerism. What is the definition of chain isomerism? Two or more isomer which has different position of chain, different parent carbon chain. Two or more isomer which has different parent carbon chain. Then it is known as chain isomer. Two or more isomer which has different parent carbon chain is known as chain isomer. Now, in case of chain isomer, what we have to do? The parent carbon chain must be different. For example, the very famous example is first one is the example normal pentane, 5 carbon chain. Second is isopentane, 4 carbon chain. And third one is neopentane, 3 carbon chain. This is our 4 carbon chain, this is our 3 carbon chain, and first one is our 5 carbon chain. So what is the relation between normal pentane and isopentane? It is chain isomer. What is the relation between isopentane and neopentane? It is a chain isomer. All these three are chain isomers. Now, what is the relation between cyclohexane and this normal hexane? This is our cyclohexane, this is our normal hexane. Are they chain isomer or not? What is your answer? Feel free to write your answer in comment box. If you are confident about your answer, you are free to write in comment box. Okay, that is my answer. Now, what is the relation between these two? These two are not isomer. They are not isomer because of different molecular formula. The first one has molecular formula of C6H12. Second one has molecular formula of C6H14. So first of all, to be a structural or stereoisomer, they must be an isomer. They are not isomer because of different molecular formula. So first of all, you should always check whether they are isomer or not. Then we will find the relation between the isomers. Got it? From this picture, it is clear that First one is linear chain, second one is branch chain. Therefore, they are chain isomers because parent carbon chain is different. Now, let's have some basic example. Draw all chain isomer of C6H14. You have to draw all chain isomer of C6H14. And the second question, draw all chain isomer of normal hexane. So you have to draw all the chain isomer of C6H14, and second one, draw all chain isomer of normal hexane. Pause the video. Try your answer, then proceed with then check your answer with my answer. First of all, pause the video. Try to draw all the possible chain isomer, whatever you think the possibility is. Now, let's try with this. First of all, we should find degree of unsaturation. The degree of unsaturation of this is 0. We already studied in IUPAC, degree of unsaturation 0. In some sources, it was written that DB, double bond equivalent, is 0. What is the meaning of degree of unsaturation 0? Means there is the absence of pi bond, there is the absence of ring. This molecular formula does not contain any pi bond, does not consist of any ring. This means it is a saturated only. So, first of all, we will draw normal hexane. How many carbon are parent carbon in this normal hexane? Parent carbon chain has 6 carbon. Now, next isomer must have 5. Just decrease the carbon chain. It is a 6 carbon chain, now it is a 5 carbon chain. Now, 1 carbon is left, we will place this carbon here. This means it is a 2-methyl pentane. So, what is the relation between first and second? They are chain isomer. Got it? Now, we will move this carbon to 3rd position. This will form, parent carbon chain is 5 and it is known as 3-methyl pentane. Now, what is the relation between these two, 1 and 3? They are chain isomers. Now, similarly, what is the relation between, now we will, total number of carbon are 5. Now, we will decrease 1 more carbon. Now, the parent carbon chain must have 4 carbon. Got it? Now, after selecting this 4 carbon, how many carbons are left? We are left with 2 carbons. So, what is the other options to place this carbon? The first option is that I can place both carbon on the same carbon. This means this is our 2,2-dimethyl butane. 2,2-dimethyl butane. Now, what is the next possibility? I can place these 2 carbon on different carbon, this and this. This is our 2,3-dimethyl butane. It is always better to write IUPAC nomenclature. Now, what is the advantage of writing this name of these molecules or compound? The advantage is that whenever you will write IUPAC name, whenever the structure repeats, the structure is identical. If it is identical, this means they have same IUPAC nomenclature. So, since IUPAC nomenclature is different, this means they are different isomer. How many chain isomer of C6H14 are there? 1, 2, 3, 4, 5. The relation between first and 5th is our chain isomer. Now, if I change the question, draw all chain isomer of normal hexane. This means normal hexane, how many chain isomer are possible for normal hexane? This means normal hexane is given. This means the relation between this and this is chain, this and this is chain, this and this is chain, this and this is chain. So, it is always better If one of the isomer is given, this means answer will be 4. We will not count the given isomer since normal hexane is given in the question. While in case of first question, C6H14, nothing is given. This means whatever the relation comes, they are chain isomer, they are chain isomer, this is chain isomer. This means they have answer will be 5. If they ask in this format, then answer will be 5. And if they ask in this format, then answer will be 4. But what I want to say, this is the more appropriate appropriate format to ask the question. This is more appropriate. This is not appropriate. This is just a weird question. He just give a molecular formula and asking about how many chain are possible. It should be always better to ask, whenever there are chain isomer is to be asked, it is better to give one isomer. So this is the more appropriate format. How many chain isomer of normal hexane? Got it? Now let's move ahead. Second one is our positional isomer. Second is our positional isomer. As the name suggests, the isomer must have changed in different position. So what is the definition of positional isomer? Two or more isomer which has different position of functional group or multiple bond or substituent is known as positional isomer. Two or more isomer which has different position of functional group or multiple bond or substituent is known as positional isomers. This wonderful animation we can learn that it is a positional isomers. Parent carbon chain is same, the ball is moving, means it is forming positional isomers. One important point to be noted in positional isomer is that for positional isomers, parent carbon chain must remain same. For positional isomer, parent carbon chain must remain same. First of all, write down the definition along with the point to remember. This point you have to learn. For positional isomer, parent carbon chain must remain same. This means chain isomer cannot be positional isomer. Additional to that point, the chain isomer cannot be positional isomer because for positional isomers, parent carbon chain must remain same. For example, let us take one basic example of 1-butene. This is 1-butene. How many carbon are in parent carbon chain? There are 4 carbon chain. And what is the position of pi bond? It is in between 1 and 2. If I move this pi bond from 1, 2 to 2, 3, so what is the relation between these two? The change in position of multiple bond, this means they are positional isomers. Now let us take one more example. This is a 5 carbon chain, both chlorine on same chain. This is also known as gem. Gem means 2 like group on same carbon. It is our gem. If I move that chlorine from first to second carbon, this means this 1,2 will form. This 1,2 is known as vicinal, means on adjacent carbon. They are positional isomer. Why they are positional? Change in position of chlorine. Chlorine move from first carbon to second carbon. Similarly, if I move chlorine to third carbon, now what is the relation between these two? These all 3 are positional isomers. In this case, chlorine is on 1,1 position. In this case, chlorine is on 1,2 position. In this case, chlorine is on 1,3 position. All are positional isomers. In all these cases, in all these three examples, parent carbon chain is same because the parent carbon chain is cyclopentane. 5 carbon chain, 5 carbon chain, 5 carbon chain. Got it? Write all these examples in your notes. Now, let's move with one more example. One more example is this. In this case, this is our 1-propanol. And what is the functional group in this case? This is alcohol. If I move alcohol from first to second carbon, what is the relation between these two? In this case, alcohol is on second carbon. In this case, alcohol is on first carbon. This means they are positional isomer because of change in position of alcohol, change in position of functional group. What is the relation between these two? This is our acid and this is also acid. Both isomer consist of acid. What is the relation? They are chain isomer or they are positional isomer. Now, in this case, total carbon chain is 4 carbon chain, and in second, the carbon chain is 3 carbon chain. They are not positional isomer. Why they are not positional isomer? Because parent carbon chain is same. In IUPAC nomenclature, if there is a presence of acid, the first number is given to carbon of acid only. This means this is a 4 carbon chain. While in this case, this is our 3 carbon chain. They are not positional isomer, they are chain isomer because of different parent carbon chain. Got it? You should be careful while determining positional isomers. Now let us take one more example. If there is a presence of this nitrile, CN, and this CN, now what is the relation between these two? This is our first carbon, second carbon, third carbon, 4 carbon. How many carbon are present in this parent carbon chain? 4 carbon chain. We will start the number 1 carbon from cyanide because it is a main functional group. Now in second isomer, if we have to determine the parent carbon chain, from where we will start? We will start with cyanide. This means it is a 3 carbon chain. So what is the relation between first and 2? They are not positional isomer. Why they are not positional isomer? Because parent carbon chain is not same. They are not positional isomer. Then what is the relation? Relation is, again the relation is chain isomer. Because this has 3 carbon chain and it consists of a 4 carbon chain. Got it? Now let us try one more example. If we replace cyanide by aldehyde, if I place aldehyde in second carbon, now what is the relation? Are they chain isomer or they are positional isomer? Just write the answer in your comment box. Now, first of all, we have to determine parent carbon chain. This means this is first carbon, this is third, this is 4. How many carbon are in parent carbon chain? There are 4 carbon. While in second isomer, how many carbon in parent carbon chain? 3 carbon. So what is the relation between these two? They are not positional isomer, again they are chain isomer. So all these three are chain isomer. In some sources, it was written that acid, nitrile, aldehyde will not show positional isomerism. Acid, nitrile and aldehyde will not show positional isomerism. This statement is true or this statement is false. Means aldehyde, carboxylic acid, nitrile, mainly carbon containing functional group. Other than ketone, aldehyde, acid, nitrile will not show positional isomerism. This statement is true or false? Will not show positional isomerism. This statement is true. We already discussed three examples of acid, aldehyde and cyanide and we determined that they are showing chain isomerism. Because the statement means there is a presence of monofunctional group. Means if it was written that acid will not show positional isomerism, this means the molecule consists of acid only. It is not consist of acid, alkene, halide. If you are taking about multiple polyfunctional group, in polyfunctional group there may be a different answer. If something is written, for example, it was written that acid will not show positional isomerism, this means that you have to consist of pure isomer only. Pure isomer means you should take example of pure acid only, not polyfunctional groups. Got my point? So this statement is correct because if we take pure aldehyde, if we take pure acid, if we take pure nitrile, they will not show positional isomerism. So write this statement in your notes and at the end of the line, it is a true statement. Now let's do some practice on positional isomerism. We can also say that chain isomer cannot be positional isomers. This statement is true or false? Chain isomer cannot be positional isomer. Yes, this statement is true. We already discussed that for positional isomerism, parent carbon chain must remain same. If there is a change in parent carbon chain, this means it will shift toward the chain isomerism. Now it is not a positional isomerism. Now let's do some practice on positional isomerism. Draw positional isomers of the following. You have to draw all possible positional isomer of the following. Draw all possible positional isomer of the following. pause the video and determine your answer, then we will discuss. Now, what is the answer of first example? This is 1,2-dichlorobenzene. Second one will be 1,3-dichlorobenzene. And fourth one will be 1,4-dichlorobenzene. They are positional isomer. Parent carbon chain is benzene. There is a change in position of chlorine. 1, 2, 1, 3 and 1, 4. They are positional isomers. What about B? This means total positional isomer are 3. If this isomer is given, the given isomer has 2 positional isomers. Now, if it was asked that how many positional isomers are possible for 1,2-dichlorocyclohexane, then what is our approach? First, we will draw all the possible structure. We will move this chlorine to the upper carbon. This means it is our gem. Now, in this gem, this is 1, 2 position, this is 1, 1 position. This means they are positional isomerism. Similarly, if we can move chlorine to third atom, this means it is a 1,3-dichloro, this is 1,4-dichloro. So how many positional isomers are possible for this 1, 2? Answer will be 3. How many positional isomers for dichlorocyclohexane? Then answer will be 4. If it was not given, then answer will be 4. Got it? Then, since it was given, how many positional isomers for this? This has 3 positional isomers. Now, why we are not drawing this gem in the first one? If I take this first example, why we are not considering this structure? Because we have to satisfy the valency of the carbon. In this case, carbon is pentavalent. So, while drawing structure, you should remember that we should not exceed the valency. We should properly satisfy the valencies of the carbon. Now, what about this? In this case, chlorine are placed at first, second and third. Now, move the chlorine atom. This is as 1, 2 and 4. This is chlorine are at 1, 2 and third carbon. In this case, chlorine are at 1, 2 and fourth carbon. Now, if I move this chlorine from this carbon to this means it is identical. 1, 2 and 4. This is identical. What is the other options? I can draw chlorine on alternative carbon. This means it is our 1,3,5-trichlorobenzene. Got it? Now, if I move chlorine to next position, this means I am talking about this position. So, this is 1, 2 and 4. So, 1, 2 and 4 is identical to this. So, how many positional isomers for 1, 2, 3 trichlorobenzene? There are 2 positional isomers. The last one drawn is identical to the second one. Now, what about D? The same, the approach in question D is similar to the question A, exactly same, just change in atoms. In this case, this is a chlorine, while in option D, it was bromine, it is bromine. Now, we will move bromine to different position. The carbon connect with the chlorine. This chlorine is constant and variable will be bromine. This means we can draw this isomer. This is positional isomer. Similarly, we can draw this isomer. This is positional isomer. How many positional isomers are possible for 1 bromo 2 chlorobenzene? Answer will be 2. These 2 are possible. Got it? Now, what about E? In option E, we have 1, 2, 3, 4 tetrachlorobenzene. If we move chlorine from 4th to 5th position, Now this is our 1, 2, 3, 4, 5. This is 1, 2, 3, 4. This is 1, 2, 3, 5. One more possibility is there. 1, 2, 5, 6. This means this given isomer has two positional isomer. If I move this chlorine from this carbon to this means it is identical to this. The other isomer formed are identical to one of the drawn isomer. Now, what about F? What is your answer regarding F? Let's draw F. This is our chloro, bromo and bromo. Now, we will move this bromine and this chlorine bromine must be constant. These two are constant and this is variable. This means the next option is this Br. They are positional isomer because of change in position of bromine. Next will be this Br. Next will be this Br. Got it? Now, what are the other options apart from this? If we move both bromine, now chlorine is constant and now I am moving both bromine. This bromine from this to this carbon, it is also positional isomer and this isomer is also different from all the drawn isomer. Now, what are the other options? I can move this bromine to this position. This means chlorine and bromine are meta to each other. Now, if I move bromine from this to this means it is similar to this one. It is identical, repeating units. We can also explain in such a way. One more better way to explain is this. If there is a presence of one group on this benzene ring, the carbon adjacent to this group is known as ortho position. Next carbon is known as meta position. Next is known as para position. Or for left hand side, similar it is ortho position and this is our meta position and this is our para position. For last isomer, we can say that chlorine and bromine are meta to each other. If this chlorine and this bromine are meta to each other, this chlorine and bromine are also meta to each other. All the valencies are meta to each, all the halides are meta to each other. So what is the answer? If this isomer is given, then answer will be 5. And if this was asked like how many dibromochlorobenzene are possible, then answer will be 6. Positional isomers possible. So for the given answer will be 5. Otherwise answer will be 6. Write all the 6 structure in your class notes. Now today was our first lecture on isomerism. First we will complete structural isomerism, then we will go for conformational, then we will go for geometrical and optical. So this will be the sequence while preparing for isomerism. What you have to do, you have to prepare all the class notes in this toppers notebook. This is our quota toppers notebook. This is notebook for isomerism. This notebook consists of short notes, this notebook consists of flashcards, this notebook consists of barcode related to the isomerism topic, animations and quizzes related to the isomerism topic. And there are a lot of blank pages where you have to prepare the short notes. At the end of the notebook, you will find some barcode related to, again, they are all related to isomerism. I will share the link on the in the details from where you can buy this notebook. So whatever related to isomerism was there. If there is any class notes, if there is any point to remember, if there is any important point which you have to learn. So this will be our companion as a class note for preparing IIT JEE examination. All the things related to isomerism must be in this notebook. Got it? Now, on next lecture, we will continue with the structural isomerism.
In chain isomers, the parent carbon chain, the number of carbons is different, not the same. Structural isomerism with different IUPAC names. In position isomers, the parent chain stays. Functional group, multiple bonds and location change their ways. Structural isomerism with different IUPAC names. Chain isomers, never position isomers will be. And position isomers, never chain isomers will see. Cyanide never form chain isomers. In chain isomers, the parent carbon chain, the number of carbons is different, not the same.